Sorry for the late post on the video, but I promise that it's going to be short and sweet because we are actually going to talk about something that you guys have already talked about. I'm pretty sure you guys did this in Algebra 1. If not, you probably did it in Geometry. Because I remember somebody in class today said, I was never really good at these problems. Alright, and the problems that I'm talking about are angles of elevation or depression. Angles of elevation or depression. I've actually got two questions right here that I'm going to do about this. I forgot to type them up and hand them out to you guys, so I'll give you time to copy them. But before we work on this, we'll do like a quick 2-second note about what is an angle of elevation or depression, if we forgot it. So first let's look at elevation, if I can spell today. Ooh. So angles of elevation and angles of depression. Okay? When you think of elevation, think of the word elevate, all right? Or you can think of elevator, all right? And those are things that bring you up, all right? So elevation angles, angles of elevation are always angles that happen when you start somewhere and you go up, all right? Right, angles that go up. And if you remember, these questions usually have pretty pictures. All right, so a nice example of this is, say, I'm like at the beach. Woo. I don't know why my leg is broken, but okay. Okay, and I'm having a good old time. Here's my beach towel. And I'm at the beach, so obviously there's got to be the sun. If there wasn't, why would I be at the beach? Happy sun. Yay. Okay, and because I'm silly and I'm happy I'm at the beach, I do something really silly and I look up at the sun. All right, don't hate, we've all done it. So here I am, I'm laying on the flat ground and I look up at the sun. This angle between my eyeballs, because I'm on the ground, all right, so my eyeballs are also where this purple line is. This angle that I formed when I looked up, since I went up, is an angle of elevation. If instead I'm talking about an angle of depression, think if you're depressed, you're down in the dumps. So in this case, angles of depression are angles that go down. Angles that go down. Now, we need to be careful though, okay? Because if you look at angles of elevation, yeah, I looked up at the sun, but I needed to kind of have this flat piece of land that I was looking on, and that's where that was the initial side of my angle. And then, because you have to have an initial side to measure your angle. So for angles of depression, we also have to have an initial side. All right, but first let's get a picture going. Let's say I've got a tree, and I fully expect you to draw these pictures in your notes. All right, say I've got a tree, and in said tree I have a bird. How many legs do birds have? 2, right? A little beak. Okay, there's my bird. This bird happens to see a worm. Isn't that what birds eat? Worms? Laying on the ground. I should have been an art teacher. All right, so now, obviously this bird that's up in this tree, when it sees the worm, it's looking down. All right, and since it's looking down, we are going to have an angle of depression. Okay, but just like for angles of elevation, we needed like a flat point, a flat initial side to start the measurement of our angle. So what we need is wherever this bird is, this is kind of going to be our flat piece. All right, you need to have this flat horizontal line to be the initial side of your angle. And actually the fancy term for this is called the horizon. Alright, you need a horizon that you're going to start measuring angles of elevation or depression from. Over here for elevation, my horizon was just the ground. But for angles of depression, you kind of have to make your horizon being the horizontal line of wherever you're starting. Then I look and I see that my bird spots my worm. So now this right here is going to be my angle of depression. Because that is the angle, the measurement of the angle as I'm looking down. Alright, do not forget that you need to have in this horizon as your initial side. Okay, a lot of people when they do this want to put their angle of depression in here. But you can't do that, alright? You need the horizontal line to be your initial side of your angle. That's why you need to put in the horizon. I'm going to erase that. Erase. Okay. Alright, before we move on to those two examples, I want to do a little throwback to geometry, because hopefully right now what we're seeing, at least in the depression picture, is that we have a pair of parallel lines that are cut by a transversal. Holy moly, yeah, geometry. Alright, because my horizon line here is going to be parallel to the ground, and this line of sight from the bird is like a transversal. Okay, so my angle of depression, which was right up here, is an alternate interior angle to this angle right here. So this angle and this angle are congruent. Alternate interior angles are congruent. So this angle of depression from the bird is actually equal to the angle of elevation from the worm. If the worm spotted the bird and was like, holy moly, I gotta run away. And not that a worm can run. Okay? The same thing would have happened over here in my angle of elevation picture. Okay, because even though I have my horizon down at the ground, I could also put a horizon up here at the sun. And then if the sun looked down at this person, which it could because this sun has eyeballs, then that would be this angle right here. And the angle of depression from the sun would be same as the angle of elevation from me, because I'm the one getting the tan down there. Okay. Alright, so let's see how I'm doing on time. Beautiful. We got 2 examples and then we are done. So, and then you guys got to take that quiz. Alright, so let's look at the first question. And I apologize that you don't have this. Alright, at a point 30, this symbol means feet, 30 feet from the base of a tree, the angle of elevation of the top of the tree is 53 degrees. Find the height of the tree. So, let's draw the picture. And I fully expect to see pictures when you guys have to do this on a test or a quiz. Alright, there's my tree. I'm at a point 30 feet from the base. Here's the base. I'm going to go 30 feet. The angle of elevation of the top of the tree is 53 degrees. Alright, elevation means I'm going up. So I'm here at my point, that's 30 feet away, and I'm looking up at the top of the tree. And it's 53 degrees. We want to find the height of the tree. Well, the height of the tree is going to be this right here. And because we live in a perfect world, that makes the right angle, right? Sure. So now we have a right triangle. So we look, is that one of our special right triangles? No. Alright, so we are just going to have to use good old SOHCAHTOA. If I look at my 53 degree angle, I know that the side, let me get a different color. I know that the side opposite of it is X, and the side adjacent to it is 30. What uses opposite and adjacent? Tangent. So the tangent of 53 degrees is equal to the opposite side, which is x, over the adjacent side, which is 30. Now we can just find x, multiply both sides by 30. All right, this you're just going to plug into your calculator, but since this is 53 degrees, you need to make sure that you are in radian mode. And when we do 30 times the tangent of 53, you get about 39.811. But this said I wanted to the nearest foot, so we'll round up to 40 feet. Dunzo. Okay, I expect there to be a picture drawn. I expect to see the calculations. Let's go down to the next one. An artillery spotter in a helicopter. I don't know what that job is, but it sounds cool. An artillery spotter in a helicopter at an altitude of 1,000 feet, that's what that apostrophe means, feet, observes the angle of depression of an enemy tank to be 28 degrees. How far is the enemy tank from the point on the ground directly below the spotter? All right, let's draw a picture. I don't know how to draw a helicopter. All right, you've got the body. It's got like the little propellers up there. It's got legs, right? It looks like a bug. It's got a little tail. And there's some guy sitting in it, so I'll put him there. Okay. And it says that this is at an altitude of 1,000 feet. So this distance right here is 1,000 feet. Straight up in the air. And now it says that the angle of depression at an enemy tank. So obviously that depression means down, which makes sense because an enemy tank cannot be flying through the air. So I'm looking down at an enemy tank. So I'll draw that over here. I have no idea how to draw a tank. So it's like a box. It's got those like weird wheels on it, right? Yeah, I don't know. I'll put a person on it. There we go. There's my enemy. Oh, and it's got that little gun thingy. Okay, there's my enemy tank. Now I'm looking down at the enemy tank. Remember, I need to have that initial side to look down from. So I need to put this horizon line in here. Okay, and looking down from that horizon line at the tank is 28 degrees. So this right in here is 28. How far away is the enemy tank from the point on the ground directly below the spotter? So here's my point on the ground, and I want to know this distance right here, x. And of course, this is a perfect world, so that's a right angle. Okay, now obviously my tank's in the way, but this makes a nice triangle right here. Same up here. Okay, so let's look. Right now, I have this triangle over here. I'll outline it. All right, I have this triangle, and I have two sides, kind of. All right, I know that the height is 1,000, and I want to find the base of it. That's my x. All right, the problem is that this 28 degrees is outside of the triangle. All right, but remember, we have this parallel lines thing rocking for us. All right, because this horizon line is parallel to the ground. So this 28 degrees up here, I also have a 28 degree angle down here because they're alternate interior angles. So now I have enough. I can use my SOHCAHTOA because this is not a special right triangle. So SOHCAHTOA. And looking at my 28 degree angle, 1,000 is opposite of it, and I want the adjacent, so opposite over adjacent. Hey, look at that, we're using tangent again. So I have that the tangent of 28 is equal to the opposite side, which is 1,000, over x. This is going to take a little bit of algebra, all right? You can't multiply by 1,000 because 1,000's in the numerator, all right? Let's get this x out of the denominator. If I multiply both sides by x, then I have x times the tangent of 28, which equals 1,000. And x is still not by itself, so I'll divide both sides by the tangent of 28. Bam! So then I'm left with x is equal to whatever 1,000 divided by the tangent of 28 is, which you will put in your calculator, which is in degree mode. And you get about 1,880.7-ish, and we want to the nearest foot, so that's going to be 1,881 feet. All right, don't forget your units. And that's that. 2 examples. We'll do more in class tomorrow. Don't forget to take your post-video quiz. See you guys mañana.